So here we go. Arithmetic series. Now an arithmetic series is highly related to an arithmetic sequence. The last problem on your homework last night had to do with what? That word problem. What was it about? Seats in a theater, right? And how many seats are in the such and such row? Well, if you're in charge of building that theater, yeah, you're a little concerned with how many seats are in a particular row. But what you're more concerned with is how many seats do you have to buy to put into this theater, right? And that's where a series comes in. A series is simply taking a sequence and adding up the terms to get a total value. Does that make sense? So we have our sequence, which is the list of numbers created by adding the same number. That's what we saw yesterday. And an arithmetic series is the terms of a sequence added together. There are two different types of series. There is a finite series and an infinite series. What do you think the difference is there?
One of them is in.
Infinite doesn't end. It just keeps going. Every time you have an infinite series, you're going to see this at the end of it. Dot, dot, dot. Because there's no end to the series. It just keeps going. A finite series will not have the dot, dot, dot because there's an end that you can see. All right? And we're going to be using this giant E-looking thing. Does anyone know what that letter is? And yes, I said letter. That is a capital sigma. It's a Greek, I believe it's a Greek S. The higher you go in math, the more Greek letters you use and the less English letters you use. Don't ask me why. But that's a capital sigma. And we are going to be using that. It's sometimes called summation notation because you are summing things together or adding them together. Sometimes it is referred to as sigma notation. I will use those terms interchangeably. They both refer to the giant capital sigma. Okay? So I'm going to kind of go through here a little quickly. And I'm going to jump down to here to show you how we actually make a sigma notation. So the first thing you do is you draw your sigma. After that, there are three things that you need to fill in for your sigma notation. One is above, one is below, and one is on the right side. Those are the three blanks that we're going to have to fill in for our sigma notation. Now, you'll notice the notation here is that AN notation, which I kind of ignored yesterday, so I'm going to do it in my notation, the f of x. My notation, it's not really mine, but anyways, let's see. Whenever we are writing sigma notation, we are always going to start off by saying at the bottom, x equals 1. That means, what that tells the person who's looking at this is we are using x as our variable, and we're going to call the first term, term 1. That's what that tells me. At the top, what I'm going to write is, in this case, for this particular sequence, I'm going to write a 4. Why do you think I'm going to write a 4? Where do you think that comes from?
It was the second thing in the sequence.
No. Not because it's the second number in the sequence.
It's the first term.
Because it's how many numbers are in the sequence. 1, 2, 3, 4 numbers. So I'm using x as my variable. I'm calling the first term term 1. And there are 4 terms in my sequence. So far, so good? What goes over here is actually my explicit formula. So, they've got the AN notation, which we didn't use. We're going to go ahead and use our f of x notation. So if I wanted to find f of x, what do I put first in my formula? 2. Why 2? Because it's the first term. Then what do I do? Plus d. What is my d value? Because we're doing plus 2, plus 2, plus 2. So my d value is 2. And then what goes in the parentheses? X minus 1. So now I got to do a little bit of simplifying. I have 2 plus 2x minus 2. What do you notice happens? those guys cancel, and I'm left with 2x as my formula, if you will, right? Now, when we put it in summation notation, we don't use the f of x equals. We ignore that part, and we just take that, and that's what goes right here. So? Good answer. All right, let's do this guy. Again, I got 3 blanks. I got to do the bottom, the top, and the right side. What do I put on the bottom? X equals 1. I'm always going to be writing x equals 1. Always. When I'm writing sigma notation, I always put x equals 1. When they give me sigma notation, such as down here, they might not, and we'll deal with that. But when you are writing it, you're always going to be putting x equals 1. What am I going to put at the top?
Infinity.
Infinity. Why infinity?
Because it's an infinite.
Because that dot, dot, dot means there is no limit to the number of terms in that sequence. And now what do I have to do to get what goes on the right? Find the explicit formula. So f of x equals what? 10, which is the first term. And then what's my d value?
-3.
D is -3, so I put -3 times x minus 1. Let's do our distributive property. And I get -3x plus 13. Is that right? And that's what goes there. Easy peasy? Could you do that on your own? Good, because that's on your homework. All right. So, back to my question about the theater seeds. How would I add up all the terms? Well, if I have a series like this, or that's the sequence, but the series would look like 2 plus 4 plus 6 plus 8, I could do that almost in my head, couldn't I? Or with a calculator. Would take me like 10 seconds and I'd be done, right? But what if there are 30 terms in the sequence? Do I want to have to add up all 30 terms? No. And that's where our formula comes in. Notice it says the sum of a finite arithmetic series. I can't find the sum of an infinite series. Why? Why could I not find the sum of an infinite arithmetic series? Because it's infinite. You just keep adding numbers over and over and over and over and over and over again. All right, so here's my formula. Now, if you are a formula memorizer, fine. I'm more of a let's figure out what this means kind of person. So to find the sum of a formula, n is equal to the number of terms you are adding. So in this case right here, if I was adding all 4 terms, my n value would be 4. Oftentimes, your n value is whatever's at the top here. Often. There are some cases, and we'll get to one here, where it's not that number, but that's usually the number at the top because it's the number of terms you're adding together. If I ignore that for a minute and I just look at this, this right here is in that other notation. We would call this f of 1 and f of n. What this is this is the first term plus the last term divided by 2. In other words, we're finding the average value of the first and the last term, because how do you find the average of 2 things? You add them together and divide by 2, right? So we're finding the average value of the first and last term, and then we're multiplying it by the number of terms. So let's look at this one. This problem right here. I could do that on my calculator pretty easily, couldn't I? 60 plus 52 plus 44 plus 36 plus 28, and I get 220. Let's solve it using the formula, though, to verify that the formula works. And on your homework, I think you have series that are also fairly reasonable to plug into your calculator. I want you to practice using the formula, though, and then you can just check it by doing this to make sure you're doing it correctly. Does that make sense? So, the sum formula. First number I need is how many terms there are. How many terms have I got here? 5 terms. Now I need to take the average of the first and last term. So that would be the first term plus the last term divided by 2. That's what I need to calculate. Question?
Yeah, the 2 is in the example, the 2 is dividing everything, including the n.
You're right. It is. If I put the 5 over a 1, that's how it gets this. Because it's multiplication, it doesn't really matter if you write it out in front or on the top. Good question. So, let's see. 5 times, what is 60 plus 28 is 88. Divided by 2 is 44. And 5 times 44 is, amazingly enough, 220. Wasn't that what I expected it to be? Okay. So again, on your homework, I want you to practice using the formula, but then you can check your answer by just adding it up on your calculator and verifying that you're getting the right thing. Okay? All right. How do I find the sum if I have something that's in summation notation or sigma notation? Well, I got to do a little bit more thinking because they don't just have it written out for me, right? So one of the biggest things that I notice about this problem is right there. They're saying don't count the first term as the first term you're adding together. Count the third term as the first term you're adding together. In other words, I don't want to add terms 1 through 22. I want to add terms 3 through 22. Does that make sense? I'm adding terms 3 through 22. In other words, what 2 terms am I skipping? I'm skipping 1 and 2. So how many terms will I actually be adding together? If there were 22 terms total, I'm skipping 1 and 2. I am adding 20 terms. Now that messes with people. It doesn't seem like it would mess with you right now, but that messes with people because a lot of people want to say, oh, that's 22 minus 3, I'm adding 19 terms. Well, that's not true because you are including the third term. You're only skipping 2 of the terms. So make sure that you're thinking in terms of, maybe I should use a different phrase. Thinking along the lines of what am I skipping, and that's what you're subtracting. All right, so when I'm finding the sum of the first term plus the last term, it's not the first term of the sequence that is the first term of what I'm adding. It's the third term of the sequence. Does that make sense? So I'm not counting the first term of the sequence or the second term of the sequence. So how do I find the first term when I'm talking about my sum would be 20 times the first plus the last divided by 2. How do I find that first number to go right there? Well, that's going to be when I plug in 3. So if I plug in 3 into here, I get 2 plus 5 times 3, which is what? 5 times 3 is 15 plus 2 is 17. That's the first term that I'm talking about as far as what I'm adding together. Is that the first term of the sequence? No, it's actually the third term of the sequence. But that's the first term of this part of the sequence I'm adding together. How would I find the last term? Well, there's 22 terms. To find the last term, I plug in 22. So 2 plus 5 times 22. 5 times 22 is 110. Plus 2 would be 112. Questions there? So? All right, let's actually do this adding. I have to do 17 plus 112 and divide it by 2. And I get 64.5. Now I'm a little concerned because that 64.5 is a decimal And none of the terms in our sequences typically are decimals. But I think that when I multiply that by 20, it's going to work out. Yep. So what is my answer representing? If I added terms 3 through 22 of that sequence, they would give me a result of 1290. Does that make sense? You guys are very quiet. Okay. Graphing. We've done some graphing, haven't we? Now they use that other notation. We know this is x and y, or x and f of x. So if I wanted to do my xy chart here, what would I put in this first column, my x column? 1, 2, 3, 4. And in my y column? 2, 4, 6, 8. Now I think I can just count these by ones, correct? Let's see. 1, 2, 2, 4, 3, 6, and 4, 8. Do I connect the dots? Now on your project that we did the other day, I wasn't too particular about the dot connecting, but now I'm going to be particular. Can we have a connected line through there? No, because you can't have a 1.5th term. Along those same lines, I can't just write that my domain is x is greater than 1 or something like that. I actually have to list these values. So I'm going to use this special little squiggly line for my domain. And my domain is my x values, so I'm just going to write down my x values. 1, 2, 3, 4. So far, so good? What do you think my range is? My y values. 2, 4, 6, 8. Easy? Okay. Let's look at this last one. Now, they give me a formula, but I know that I can't plug in just any x value that I want to. I have to plug in certain x values. I can't plug in any fractions or decimals, right? And they're telling me plug in the number 1 because it's got that or equals to, and the number 5 because it's got that or equals to, and all the numbers between there. So what's my domain going to be, or my x value is going to be? 1, 2, 3, 4, 5. And I can go ahead and write that as my domain. 1, 2, 3, 4, 5. Now this one's a little trickier. How do I find my range? Plug it into the equation. So to find the first term, I'm going to plug in 1. Well, 4 times 1 is 4, and 14 minus 4 is 10. How would I find the second term? Plug in a 2. 4 times 2 is 8, and 14 minus 8 is 6. Now I could continue that process, couldn't I? Or there's a little bit of an easier way to think about this. This is an arithmetic series, or arithmetic sequence, which means that they are adding or subtracting the same number each time, right? What are they adding or subtracting? In other words, what is my d value?
Minus 4.
Isn't my d value negative 4? So I can just continue to subtract 4, or add negative 4. So I would have 2, negative 2, and negative 6, and that's a bit easier for me. So what's my range? Let's go ahead and fill that out. 10, 6, 2, negative 2, and negative 6. Okay? Now, I don't think I can count by ones on this one like I did before. I think I can count by ones on my x-axis. I think I'm okay. But up and down, I can't get from 10 to negative 6 counting by ones because I only go up 1, 2, 3, 4, 5 lines. So what do you think I should count by vertically? 2s. So you're going to have this on your homework where you're going to have to change the scale. In other words, if I'm going to count by 2s, give me a 2 right there that shows me that I'm counting one line as 2. You don't have to label every single line, but you just have to at least label one. If you don't label anything, You are telling the reader that they are counting by ones. So if you're not counting by ones, then you must label it. So let's plot these now. 1, I should probably put a little 1 there just to show that I'm still counting by ones here. 2, 4, 6, 8, 10. 2, 2, 4, 6. 3, 2, 4, -2, and 5, -6. Do I connect my dots? Nope. Okay. All right, let me explain your homework to you. So for numbers 1 through 6, I have provided you graphs. You do not need to find a sum of anything. You do not need to find an explicit formula. All you need to do is graph the sequence. Now, it says scale the horizontal n-axis, or your x-axis, by ones. In other words, I'm assuming that you are counting by ones here. You don't need to label that if you don't want to. However, this axis, you're going to have to figure out what to count by. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you need to go from 20 to 60. I'm thinking maybe count by tens, in which case, give me at least one value on that y-axis so that I can see what you're counting by and then go from there. Okay? That's what you have to do from 1 through 6. After that, you have 4 questions that say rewrite each sequence using sigma notation. Then evaluate using the sum formula. So, you're going to need to come up with your sigma notation. So you start off by writing your sigma. Fill in your blanks there, there, and there. And then also, this is a place where I want you to practice finding the sum using the sum formula. But since there's only a few terms, you can also check yourself by just adding them up to make sure you're using the formula correctly. Does that make sense? On the back side, these ones, you do not need to write the summation notation. I just want you to practice using the sum formula. And again, you can add them up to check that you're doing it correctly. And then these ones, I give you the summation notation. I want you to use the formula to find the sum. So that's just like what we did with this guy right here. Make sense? All right, happy studying.